Welcome to our fourth and final Schulman lecture for the semester. I'm not saying that we saved the best for last, but I'm not denying it either. Our speaker today is Professor Elizabeth Spelke. She is the Marshall Berkman Professor of Psychology at Harvard, where she also co-directs the Laboratory for Developmental Studies. She is certainly one of the world's most prominent and impressive cognitive scientists, and in my only hesitation in saying that is that I'm not sure the word cognitive is necessary. Liz is also just one of the world's most prominent and impressive scientists. This is true in terms of both concrete methods and abstract deep theory. Methodologically, Liz has pioneered new ways of reading the minds of babies with elegant behavioral measures. Theoretically, she's used these methods to transform our understanding of our own minds and where they come from. And she has done this not just in one or two case studies, but for essentially every primary aspect of our minds that we care about, characterizing what she calls our core knowledge of objects, space, number, physics, geometry, social agents, and beyond. And I think those categories are very important, but also sort of a little dry and abstract. In the context of doing this, Liz has also studied everything from food and shadows and maps to race and accents and kinship to music and singing to a paper in Science earlier this year that looked at infants' appreciation of intimacy and saliva sharing. That's the first time we have uttered that phrase in the Schulman seminar. In almost any aspect of these areas and beyond, you can find her work both at the foundations and the cutting edge. As one person has called her, she is the, quote, preeminent researcher of the basic ingredient list from which all human knowledge is constructed. And if this is starting to sound a bit too grandiose, I will just note that a profile of her once noted that she had summarized on her lab's bulletin board her current research program in terms of, quote, blocks and holes, talking blobs, and wet animals. And I will confess, Liz, I've never known, I get the other two, I've never known quite what to make of the wet animals thing, but now that I see the saliva sharing, maybe I'm starting to see that. Liz has done all of this while being one of the most positive and nurturing people in our field. The list of students she's worked with is really a who's who of cognitive science at this point, and she is a role model for so many of us. In fact, if you'll permit one slightly disturbing story, I've only ever had one negative thought about Liz in my career. It was early on, and it was my mistake. When I was a second-year graduate student, I think in 1995 or some prehistorical time like that, I wrote one of the first papers I had ever written, and for some reason it occurred to me, as it happens to one, that like Liz Spelke needs to read this paper. And so I emailed her out of the blue as a graduate student, and I said, hey, I've done this work on blah, 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 and would you be willing to take a look at it? And she responded in about like 10 seconds by email and said it was such a warm and nice message saying, I would love to check that out. Please send it to me. It sounds so interesting. I'm in France this summer. Please send it along. I'll get you back comments right away. And I was so excited. And she never wrote back to me. And so I thought that was sort of the genesis of this negative thought that for years I thought like, wow, she seems so warm, but it was like a con. She never got back to me. And then I finally met her years later. And she seemed so nice, and I was hesitant to bring it up. And then 2 years after that, this is like 6 years after I had sent this paper, I got the paper back. And this is the slightly disturbing story. That paper had been in the mail on flight TWA 800, which for those of you who don't remember this is a flight that famously was on its way to France and crashed over Long Island Sound. They recovered the paper from the bottom of Long Island Sound, and it had been in the custody of the agencies investigating the crash for years. I don't think they found any causal connection between the work, though. So, Liz, I apologize for thinking that negative thought about you for all those years. It wasn't your fault. I'll end just by noting that Liz has won basically just all of the honors that our field has to bestow. Among many others, she's a member of the AAAS and the National Academy of Sciences. She is a corresponding fellow of the British Academy for the Humanities and Social Sciences. She and her work have been profiled in both the New Yorker and the New York Times. She's won the Jean Nicot Prize, the Kurt Koffka Medal, the Heineken Prize for Cognitive Sciences, the William James Award from the American Psychological Society, the Distinguished Scientific Contribution Award from the American Psychological Association. I think most important, she won a Distinguished Alumni Award from the New Canaan Country School here in Connecticut. But she has not yet delivered a Schulman lecture here at Yale. Please welcome Elizabeth Spelke.
I don't know whether to thank you or not for that introduction. On the one hand, I'm not going to talk about any of those lines of work. If you want to know about saliva sharing, you're going to have to ask me over drinks or something afterwards, okay? Second, while I might have been innocent on that particular occasion, anybody who knows me knows that I'm way more enthusiastic about what I say I'm going to read than I actually end up having time to read. So while I might have been innocent in that particular case, you shouldn't conclude across the board that that's going to be true. One thing I do have to say is I'm again coming from Paris, and I am so happy to be here with all of you. This is my first real talk, in-person talk, since the pandemic started. It's been totally fun. I've had a really great day so far, and I'm very happy to be here with you. I'm also under strict orders that I can't go over 45 minutes, which is one of the reasons why I'm not going to talk about any of the topics that were on Brian's list. And also, a reason why I've decided to do something that I've actually never done at a talk before, which is to start with the final conclusions, so that if my optimistic assessment that I'm going to be done in 45 minutes turns out to be wrong, you won't be missing the message of this talk. So there are three general conclusions to this talk. The first is that between our perceptual systems and the systems in which we use our explicit concepts and form beliefs and communicate our beliefs to others, there's an important level of representation. It's a level of representation that I think is often not recognized in either philosophy or the sciences. I think certainly when I was a student, I was taught that there were two kinds of systems in the mind. There were the automatic systems that control our perceptions and our actions, and there were the conscious, deliberate, accessible systems in which we formulated and expressed our beliefs, and that the mind divided into these two parts. Today, they're sometimes called things like thinking fast versus thinking slow, peripheral processes versus central processes, that this is how the mind divides up. But I actually think there's an important level of representation between those two levels. I don't deny the existence of either of those two levels, but I think if we really want to understand how our minds work and answer some basic questions about how are we all the same and how are we different, how do children learn, that it really helps to focus on a level that mediates between and remains constant over all of the changes in what we perceive and what we believe. Now, the second general lesson is that at this level, concepts that are highly general and that capture properties of the world that are highly abstract actually emerge in development before concepts that are more specific. And I think this is true both when we look over human ontogeny and also when we look over the evolution of life on Earth. If that's true, it implies that the ways in which infants and other animals are like us are not that they share our basic reflexes or sensory experiences, but that they share our sensitivity to the basic abstract properties of causality and space and time that structure our world. Those are the ways in which other animals are most like us. And I think this also goes against widespread intuitions about what we have in common with our house cats or what we as adults have in common with newborn infants, that we might share some of their emotions, we might share some of their sensory experiences, some of their reflex actions, but surely not the basic abstract distinctions by which we understand the world. That, I think, is how we intuitively tend to think about infants and animals. But I think this research suggests that that's not right, and that it's really the abstract concepts that are most likely to be common to us at all ages and also common to different species. And hence the first part of my title, The Primordial Blessing of Abstraction, which I'll try to unpack over the course of this talk. And then the third lesson goes against sort of the most fundamental thing that people were always saying to me when I was a student, and then again when I started doing research in this field, and would find evidence that some abilities seem to be innate. The idea was that something is either innate or it is learned. And if it's innate, then it's not learned, and if it's learned, then it's not innate. And that's all, of course, true. But what people seem to often think followed from that was that the more innate knowledge you have, the less you have to learn, because all the stuff that you know that's innate is not learned. I actually think that the reverse is true, that the more innate concept, well, let me put it this way. If we lived in a perfect, unchanging world, where throughout the evolution of life on Earth, the environment stayed exactly the same and predictable in exactly the same ways, then maybe it would be true that the more innate concepts you had, the less you needed to learn. But in the actual world that all animals live in, the world is changing and it's uncertain. And in that circumstance, the more innate concepts you have, the more of a learning problem you face, because you have to discover which concepts to call on in any given situation, which ones are going to be useful and what they're going to be useful for. And this is what I call the curse of a compositional mind. So what I want to do today is, my talk is in two parts. The first part is going to be an attempt to convey to you in 30 minutes what is soon to appear in a humongously long book, which covers exactly 1 year in human life. It starts at birth and it goes to 1 year of age, and tries to talk about what I think the cognitive sciences have learned about what infants know over the course of that first year, especially in the early part of that first year. So I'm going to spend 2/3 of my talk focused on that. And then I want to turn to the problem that I'm working on now, and which I hope will someday become volume 2 of the next book, and the next and last book in this series. I want to turn to the question of how children learn, and in particular, focus on what I think is a learning process that's unique to our species, and that helps account for how we can be so similar to other animals at birth in our the abstract concepts that we apply to the world, and yet find ourselves on such a different path of development when we start to grow explicit knowledge. So, to start with what infants know, let me see if I can get all this on one slide. They know that there are objects, that the world that they have entered is going to have bodies in it that are solid and that move continuously through space and that interact with one another on contact. And I think they may also, this knowledge may be accompanied by capacities to form mental simulations of these objects and their interactions. They know that there are places, and that places are arrayed on a surface over which you can navigate. That surface, depending on how it's contoured, will afford navigation on some paths and not others. And with that surface, as you travel over it, you can learn how what different paths connect different places in the space to one another. Most tentatively, I think that they know that there are living beings in the world with characteristic forms and characteristic functions for us and for themselves that live anchored to this surface. And their forms and functions both may be captured initially by something like shape skeletons. And now coming away from the tentative more to things where there's more evidence, I think that they know there are agents that cause their own motion, and by moving cause changes in the world, and that they move by pursuing goals efficiently to bring them valued and accessible objects. I think they know there are social beings who share their experience, who experience the world as we do, and who share their experiences with one another or with us in states of engagement. And I think they know that they have a system for representing when any of the entities I just described congregate in groups or are arrayed in sequences of events. They have a system for representing their approximate numerosity, a system that they can use for diverse purposes, but maybe especially for learning, probabilistic learning about the properties of the world, and also making decisions and planning actions. So these different things that infants know, I think, stem from 6 different cognitive systems that I call systems of core knowledge that have a number of interesting properties in common. The most important is that they center on abstract concepts that are interconnected to one another. And here I've just put pointers to the distinctive concepts that I think arise from each of these different core systems. But for the rest of the properties, I want to take the place system to quickly kind of unpack them for you. The second property of these core systems is that they're limited. So when infants or inexperienced animals begin to navigate through space, they're navigating through a very rich environment where they have multiple systems that they can use to pick out landmark objects, to pick out all different kinds of surfaces, to see colors, to see shapes, and so forth. But when they face the task of determining where they are and what paths they should take to get from where they are to somewhere else in the environment, they disregard almost all of this information and rely on only one thing, which is the ground surface over which they move and its perturbations. That's an example of a limit on a core system, a limit on the things that it serves to represent. In addition to being limited, the representations from the core systems are shared. When we look at the abstract properties that characterize them and the limits for each system, we get evidence that they're shared by other animals. That is, it's not only the case that we see objects and that other animals see objects, but we see objects under the same conditions and with the same, by using the same abstract properties that other animals do and with the same limits on what we represent that we find in other animals. Now that gives us reason to believe that these systems are ancient, that they evolved long before we emerged as a species and ancestors that are common to us and to other animals. Now, because they're ancient, they can be studied in animals not only at a behavioral level, but at a neural level. And this, is, of course, has been done famously and richly in the case of the place system, providing evidence that navigation relies on specialized neural mechanisms in the hippocampus and surrounding cortex, that these mechanisms are present in animals throughout their lives. They were found first in mature animals, but then also tracked down in development and found in animals at the very beginning, just beginning to navigate through the environment. Armed with this information, functional brain imaging studies revealed the same mechanisms in humans, providing yet more evidence that we share common systems with these other animals, and also providing evidence that in humans, as well as other animals, these systems are present throughout life. They're not scaffolding that you use as an infant to get cognitive development going and then throw away as you latch on to other kinds of concepts and representations. Rather, they continue to function in us throughout our lives and in other species as well. Now, because these systems continue to function in adults, you can do experiments like some of the gorgeous experiments that Brian did generations ago. You can do experiments where you catch them in action in adult minds. And when you do this, if you then ask people, what are you thinking about while you're in this experiment, you discover that these systems are operating automatically and effortlessly and unconsciously. But you also discover that different systems, representations from different systems, compete with one another for attention. So again, to use the place system as an example, when adults are in a virtual navigation task, so they're navigating on with a joystick, looking at a computer screen through some environment, we're able to navigate to find our way to an object in at least two different ways. One, by using objects in the environment as landmarks and marking where we are relative to them. And two, by using the ground surface and its perturbations over which we're moving. Now, what you find in adults is we can use both of these systems, but on any given occasion, as we use one, it will tend to suppress the activity and the neural mechanisms that support the other system. So you see a competition between them. And by the way, if you then ask adults, what were you doing on that trial? And was it any different from what you did on other trials? They generally cannot tell you. It's not that we're consciously making decisions that we're going to rely on one system or the other. It's that they're automatically activated, but in a competitive, resource-limited manner. Finally, these systems support children's learning. In the case of the navigation system, learning the layout of their local environment, where things are and how you get from one place to another. And there's some evidence in the case of the place system that this learning and also decision-making about which path to take through the layout are heavily influenced by a capacity that's been found both in adult animals and also in young animals to form mental simulations of travel through the environment. So when an animal confronts a choice point, a new choice point that it hasn't confronted before, taking either of two different paths to get to a goal object, it may well stop at that choice point and simulate one path or the other path. And you can track these simulations if you're monitoring what activity is going on in their hippocampus. And then the ultimate decision that the animal makes the effectiveness of that decision can be linked to the effectiveness of the simulations that it had engaged in. And that same process has also been found in young animals and also in human adults. So in the case of place representations, there is evidence that processes of mental simulation enter into our learning about the layout of the environment. The reason I qualified this conclusion here is that, to my knowledge, there is no evidence for any direct evidence for mental simulations in human infants. So that remains an untested hypothesis. But the last general thing I want to say before plunging into some more details is that these different properties of core knowledge systems are not just a random laundry list of properties that have collected over time. I think they're interestingly related to each other. And that any system that has some of these properties is highly likely to have all of them. And to see this, let's start with the property of the ancient origins of these systems and think back to creatures who lived hundreds of millions of years ago, common ancestors to us and some of the fish, or maybe even fruit flies in some cases, and other animals who navigate through the world in some of the same ways that we do. And imagine that this ancestor lived in the water and fed on a certain kind of food, and the environment in which it lived lasted long enough that it was able to evolve multiple mechanisms for guiding itself to the sources of food. First of all, the sources occurred in predictable locations, so they could, by representing their own position and the distances and directions of those locations from their home position, they were able to use the geometry of the layout to get to navigate to food. But the food also probably had a characteristic odor, chemical composition, which might have created gradients in the water that they were swimming through. And they may well have evolved other mechanisms for detecting the food visually or detecting the chemical gradients. But now think about their descendants. Over subsequent evolution, the environments changed. And the animals changed. Some of them grew bigger, they grew smaller. Their energy requirements were no longer met by that kind of food. They had other kinds of food. So any mechanisms that were specific to the smell or the sight or the chemical composition of that food would be no longer relevant to the descendants from that ancestors on the way to getting to us. But for all of those intermediate species, the Euclidean structure of the environment would have been the same. The mechanism for navigating by the distances and directions of food sources from the animal would be useful no matter what environment that animal was in. So any system that was ancient is very likely to focus on properties of the world that are abstract, that apply in all environments, and that are limited, that don't apply to things like what stuff looks like, what it smells like, the superficial properties of things that differ from one environment to another. But if a system captures abstract properties, those properties are going to be extremely useful if they apply in all environments, and they're going to apply not only in all environments, but to people of all ages, even as people change their environment. If their lifestyle brings about, they migrate or something, they travel to new environments. These basic abstract properties of the world will apply in all of those environments, from which it follows that these systems, if they emerge in infants, are very likely to stay present and functional throughout our lives and support our subsequent learning and our subsequent reasoning, no matter what problems we find ourselves confronted with. What's more, the systems are likely to be neurally specialized and to operate automatically and unconsciously, because if you have a system that works in every environment that you're ever going to be in, then you don't need to waste your conscious decision-making resources on figuring out, should I be using it or not? Yes, you should always be using it. You should be using it automatically. However, there is a problem, which is that, I guess I didn't put this property on the list, but there is a problem that we have multiple such systems, but we can only do one thing at a time. So I think it makes sense that these systems, although they're automatic and operate unconsciously, nevertheless compete for resources so that animals aren't pulled in multiple different directions at any given moment in time. And then finally, I think these systems may serve to simulate the entities that populate the world that we find in these systems, because they're supporting our learning automatically and effortlessly. They're able to do this from the very beginning, since they're focusing on abstract properties that don't depend on what things are particularly going to look like in one environment than relative to another. This could be a useful way to prepare animals for the world that they're going to be encountering. So that's all the conclusions of the talk. Now I can actually get to the beginning of the talk, and thank you. And what I want to do is focus on 3 of these systems to set up the second part of the talk, where I ask how children learn. I think a lot of how children learn depends on the ways in which, as infants, they represent objects and agents and social beings. Now, I was actually here, and some of you heard me talk here before the pandemic. So I want to go very quickly over stuff that we already knew back then. I'll only talk very quickly about what infants know about objects, but then tell you about some new work we've been doing on infants' representations of agents and social beings, but not saliva sharing, Brian. Sorry about that. Okay, objects. So what do babies know about objects? Only really abstract things. They don't know what they're going to look like. They don't know what kind of categories they're going to fall into. But they know that out there in the world there are going to be bodies that move as cohesive wholes that are fully interconnected. So if parts of them are moving together, there's going to be connections between those parts, even if they aren't directly visible. And that move on unique connected paths through space and over time. So if an object appears behind the left screen, and then an object comes into view, disappears behind the left screen, and then an object comes into view from behind the right screen, but there was no object moving between the two, infants can conclude that there were 2 objects participating in that event. And if a screen comes up and covers an object, infants can predict that that screen should, it's rotating backward. Infants can predict that that screen should stop its rotation when it reaches the point where that object is located, even though it's no longer visible, because 2 things can't be in the same place at once. And if one object, that red block, moves toward a blue cylinder that's initially stationary behind a screen, and then after it disappears, the blue cylinder starts to move, infants infer that the block will have contacted the cylinder, that they interacted on contact. Now, interestingly, research by Susan Carey has shown that if one of these it's not that infants can't tolerate violations of these properties, you can violate them, but if you violate one of these properties, they suspend all their predictions about the others. So the properties seem to be interconnected. These aren't just separate things that infants know about objects. They're connected together, and they rise and fall together. And all of these abilities, they've been studied in infants at a variety of different ages. They've been revealed in human infants at different ages. And very few of them have been tested in newborn infants, but all of them have been tested in controlled reared animals of various species. And when tested, they've been found to be present and functional on an animal's first encounter, perceptual encounter with an object. Okay, but these abilities are extremely limited, and I'm going to mention just one limit from a classic experiment conducted 25 years ago, or set of experiments by Fei Xu and Susan Carey with 10-month-old infants. These were studies in which infants were shown objects that very likely were familiar to them, like a shoe, baby's shoe that went behind a screen, and a rubber ducky that came out from the other side of the screen. And after seeing that event repeatedly, they were asked, in effect, how many objects are behind the screen by taking the screen away and on alternating trials revealing either both objects or only one of them. Measuring how long infants who hadn't seen the previous events looked at those two displays, and comparing that to how long the infants who saw the previous events looked at them. What they found is that the previous events in no way disposed the infants to conclude that there were two objects behind the screen. They seemed completely open-minded about whether there were two objects behind that screen or one shoe that turned itself into a duck during the time that it was hidden. Now, you could think, well, maybe this is just a memory problem. The kids weren't keeping track of the appearance of the objects. But Xu and Carey showed that that wasn't true. Because if you measured how interested they were in the events where the shoe and the duck alternately appeared, relative to events where the duck appeared on both sides of the screen or the shoe appeared on both sides of the screen, they were more interested when there was a change in features. Also, in tasks involving no memory demands, where the question for the infants is not what's happening when these things are out of view, but rather, if I lift the duck, what's going to happen to the truck? Will it come with it, or will it stay on the table? Are these one connected body, or are they two separate bodies? The infants were neutral between those two possibilities, even as many of them demonstrated that they recognized the duck by saying quack, quack while they looked at this display, or the truck, and so forth. So it looks like infants can recognize some objects and even imitate their functions without using that information to answer the question, where does this object end and the other one begin, to track objects over time. So this suggests that when reasoning about object motion, infants are representing objects as bodies, but not as kinds with characteristic forms and functions. I think a way of thinking about this is these are telling, this is a system that's telling infants what individual things are out there in the world, but not how should these things be categorized and what generalizations should I form over those categories. And here I think there's a parallel with the physics engines that Josh Tenenbaum may have talked about when he was here, in which I know some of you have been interested in working on, that simulate object motions and interactions. But let me move on to some stuff that we're working on actively now. Infants' early developing understanding of people as agents. So over the last 25 years or so, we've learned a fair amount about, people have learned a fair amount about infants' expectations about how agents will and will not act. We've learned that agents tend to act efficiently to achieve their goals. So if an agent consistently reaches for an object over a barrier and then the barrier is removed, they'll change the trajectory of their reach to the more efficient direct reach for that object. We also know that infants will take higher cost actions to attain goals of greater value. So if infants see that the little red agent is willing to climb a steep hill to get to the yellow guy, but only a shallow hill to get to the blue guy, then when the yellow and blue guys both appear on a level playing field, they expect the agent to go to the one that they had taken a more costly action to get to previously. And finally, we know that babies expect that agents will act on things that are perceptually accessible to them. When they do, their actions will reveal their relative value that they give to each of these objects. So this is work by Yu-Yan Luo and Susan Johnson, in which on the two top lines you see experiments in which an agent can see each of two objects and reaches for one of them. And under those conditions, infants infer that the agent prefers that object to the other object, contrasted with two conditions in which the agent can only see one of the two objects, either because the other is fully hidden behind a screen or because their back is turned to the other object. And in that condition, they make no inference about whether the agent prefers the object that she reaches for to the other object. Only when she can see it do they think that there's a preference. Now, these properties also connect to each other. Inferences about preferences connecting to inferences about visibility, inferences connecting also to inferences about the amount of cost you would take for an action, and so forth. And they also connect to a further abstract property, namely that agents' actions cause changes in the world. And for this, I want to talk very quickly about a study that I talked about at much more length when I was here 3 years ago, that showed that babies, when infants of about 3 months of age, that is, infants who are not yet able to reach for objects and pick them up or act on them systematically, basically all a 3-month-old baby can do, if you show them an object within near reaching distance, is they kind of go like this and look like they would really like you to give them the object, but they can't actually get it themselves. And if you move it close enough that they might bump into it, they actually bat it away, okay? They can't actually engage in a coordinated reach for an object. So we take infants of that age and ask, if you show them another person acting on an object and causing a change in that object on contact, do they see that as a goal-directed action? And in particular, will they infer that it'll be efficient? So in this condition, Shari Liu showed a person, actually she used to be here as a postdoc at one point, Alia Martin, reaching over a barrier, touching an object, and the object lights up and makes a noise. And then the barrier is removed, and the infants see a direct reach and an indirect reach alternately for the object. And the question is, which did they expect to see? And she compared this condition to a condition that was made with exactly the same videos, differing only in 1/2 second. For this condition, the video was modified so that the hand stopped short of the object and froze in that position, and then after a 1/2 second gap in time, the object lit up. So no spatiotemporal contiguity between the action and the effect on the object. And what she found was that in the contact condition, the babies expected the efficient reach. In the no contact condition, they did not expect the efficient reach. They had no expectation. So it looks like before infants can pick up an object themselves, they construe other people's actions as costly, but only if they also see them as causal. Okay? In the non-causal condition, that effect didn't occur. Now, those are the interconnected abstract concepts that we see in young infants, but there's a limit to young infants' agent knowledge of their knowledge about the actions of agents that was discovered by Amanda Woodward and Jessica Somerville that we've been curious about. It comes up in a simple situation that works beautifully with a 5-month-old infant. 5-month-old infants, by the way, are now by then in the business of picking up objects and manipulating them. And these infants are shown a person who consistently reaches for one of two objects presented in constant positions, in this case, reaching for the ball, which is always on the left. And then Woodward asks, how are babies understanding that reach? How are they representing that action? By allowing babies to see that event repeatedly and then reversing the positions of the two objects and alternately presenting a reach on a novel path to a novel location, but where the same object is, versus a reach on the familiar path now to a novel object. And at 5 months of age, babies expect the reach on the novel path to the familiar object and look longer at the other one. Okay? So they see this reach as directed to the ball, in this case, not directed to a particular location in space. That's at 5 months. At 3 months, they saw something very different. The babies were equal had no expectation about whether where the reach would be directed. Then later, they saw a different development that also seemed to track the development of the baby's own action capacities. This is a case where, studied at length by Piaget many generations earlier, where babies have to do one thing, like they see somebody who does one thing, pulling on a cane, in order to create the conditions where they can do a second thing, pick up an object that was previously out of reach, but that the cane brought within reach. And when they presented this event to 12-month-old infants, the infants recognized that the goal of the action was the toy that was out of reach. By that age, they're also inclined to use canes to pull toys into their reaching space. But at 8 months, before they engage in that two-step action, they took the goal to be the cane itself, not to be the toy. So again, it looked like there was a limit to infants' understanding of other people's actions, and that the limits are overcome at the point at which the infants themselves master those actions. But this raises the question, how do infants understand actions that they can't yet perform? And what Woodward and Somerville suggested is that they don't understand them. They see the behavior of the agents in these studies as purposeless until they get to the point where they themselves have and can realize these purposes, and then they start endowing other people with them. But we thought maybe we could get young babies to succeed earlier in understanding that these actions were goal-directed. And we now, as Brandon Wu and Shari Liu, in our first attempt to do this, focused on this same Woodward situation that I just described with 3-month-old infants. And we just did one thing different. Based on the last study I told you about that Shari had performed, we had a person reach for one of two objects, the bear or the toy, but always consistently for one of them. But at the point at which the person contacted that object, both objects lit up. Okay? And the thinking was, well, we know that action at a distance doesn't work. So touching this, the babies shouldn't think that that will have a causal effect on this object, but they should think it'll have a causal effect on that one, and maybe that would lead them to succeed in a Woodward experiment. So we then switched the locations to see what would happen, and I fully expected that this study would work. And this is the point at which, this is what I'm in this business for. Okay, I was dead wrong about that. The babies taught me something. They looked absolutely equally at the change in object and the change in location. They had no preference for one over the other. So I needed to rethink what was going on here. And it seemed like there were two possibilities, probably maybe more than two, but these were the two that we focused on. One is the Woodward-Somerville possibility. Babies are just seeing these the people as engaged in aimless, purposeless, goalless movements, okay? But it seemed like there was a second possibility. Maybe in the same way that babies use core knowledge of objects to represent individual objects, but not kinds of things, maybe they use core representations of agents to represent individual actions without understanding that there are kinds of actions. There are acts of navigation that serve to take you from place to place, and there are acts of manipulating objects that serve to get you to particular objects that have particular affordances that you want to capitalize on. Maybe they don't have that second level, in which case they might perfectly well think of this person as acting in a goal-directed manner, but be open to the possibility that that goal could be either an object or a location in space, okay? So to distinguish those possibilities, Brandon and Shari ran two more experiments. Here's one of them. This experiment involved familiarizing infants with reaches to one object at two different locations. So for some of the infants, here's what the familiarization was. This person always reached for the bear, but on alternating trials, the bear appeared in the middle of the display or on the left side of the display. Across different babies, we varied which object was the goal and whether it was on the left or on the right and so forth. But they repeatedly saw that the guy was going for the object, regardless of which of two locations it was at. And then they were tested with that object in a completely new location that had never appeared before versus the other object which had never been reached for in one of the two familiar locations. So that's the Woodward situation. but with information that it's the object and not the location that matters. And in this case now, we see the Woodward effect. We see the infants expecting a reach to a new location for the familiar object to be more similar to, they deem that to be more similar to what they were seeing before, and therefore less newsworthy, and so they look at it less long. Now that could be for either of two reasons. They're 3 months old. They've been looking at events in which other people reach for objects and pick them up and manipulate them. That's how they get all this nice motion information about objects most of the time. So they could be predisposed to learn that reaches tend to be directed to objects, possibility one. Or possibility two, they could be completely open-minded and be equally ready to learn that reaches are directed to locations in space. So the last experiment tested for that. To test for that, we have to have reaches to one location but two objects that can appear at that location, and then we need a third novel object which is only going to appear at test. And at test, you contrast a reach to a familiar object, a previously reached for object at a new location with a new object at the old location, and now we see an effect at least as large of learning to expect a reach to a location as learning to expect a reach to an object, okay? So I conclude from this that infants can quickly learn at 3 months that a person's goal is either to get to a particular object or to get to a particular point in space. And what they learn depends on the nature of the evidence that they're getting. But before they learn that, they represent other people's actions as goal-directed. They know this action has a goal. They just don't know which of two goals it is. And they need to get information about that. But there are limits to, interesting limits to infants' knowledge. And I want to talk about one using experiments on 15-month-old infants that gets to issues about experience and mental states that I know from conversations today and yesterday that many of you are interested in, and also I'm puzzling over these experimental results now. Okay, these are studies with 15-month-old infants. And the first of them, they both ask, what do infants understand about other people's mental states when those people are viewing the same array that you're viewing, but from a different perspective? So here's a situation where infants were first shown, you don't see this here, but they were first shown that there are two photographs of faces. By the way, all of these studies, including the ones I just told you about, were conducted over Zoom during the pandemic. This is all new work. And most of them are not published yet. I'd love people's reactions to them. But initially, they see just the two photographs. So they're in view for this person, this actor, and also in the infant's view, of course. And then the occluders come down. And the occluders are placed so that one of the objects is hidden from the baby's view but visible to the actor, and the other is the reverse. And the actor now points to either consistently to the object that he can see or to the screen covering the object he can't see. Which of those two he points to is counterbalanced across infants, but infants consistently see him doing one or the other of those actions. And the question is, how do they represent that action? Do they represent it that he's pointing to the screen that I'm looking at, or do they represent it as he's pointing to the picture that he's looking at? Okay? And to get at those two distinctions, after that familiarization, the person moves to the other side of the room, so his perspective and the infant's perspective coincide. And now, depending on which perspective they attributed to him, they would see one or the other of these events as novel. And in that situation, this is the event that corresponds to what they saw before. They see this one as more novel and look at it longer, providing evidence that they do take account of the visual access of the other person to the object. We showed this in this study at 15 months. It had previously been shown by Luo and Johnson at much younger ages, at 3 months of age, using a simpler situation, but logically testing for the same ability. So that's something, this is a case where they seem to succeed in distinguishing their own mental state from that of another person. Contrast that with this situation. We've got the same guy, we've got the same pictures, but now instead of a picture being either visible or hidden, a picture is either upright or upside down. And one of the two pictures is upright, and the other picture is upside down to the actor. And the actor's action is to take the picture that's upside down to him and turn it so that it's right side up to him. Okay? And the question to the baby is, what's this person doing? Is he taking a picture that he sees as upside down and making it right side up, as I just described? Or is he taking a picture that's right side up, namely what the baby sees, and turning it so that it's upside down? And in this situation, they do the egocentric thing and represent, the evidence is that they generalize to this display and look longer at this one, as if they represented him as taking an upright picture and turning it upside down, what they saw from their perspective, not the agent's perspective. So as old as 15 months, infants don't seem to infer that agents' actions reflect their experiences of the objects that they're acting on. They depend on the visibility of the objects that they're acting on, but not on the ways in which they themselves are construing that object as right side up or upside down. I'm not going to show you any more data, but we've done this experiment multiple times using different variations on this method, and that's consistently been the finding that we get. We don't yet know why this is. We don't know whether this is there's one thing that's different about this case from the goal case, the location versus object case I described before, which is it's not the case, it seems like it's not the case that they understand this guy's got experiences and that experiences can differ, but they don't know what his specific experiences are. If that's all that was going on, then they should be equal between these two events as they were between the place and the location, and that's not what we see here. But we don't know what is going on. One possibility is that kids are just locked into their own view of the world. I think we have evidence against that, but I won't talk about it now since you're looking at your watch, which tells me, oh no, that's terrible, and I haven't gotten to core social cognition yet. Okay, I have to go faster. All right, never mind. There's at least two possibilities left once we rule that first one out. One is that they don't have a sense of other people's experiences at all, only of their own. I think that's not going to turn out to be true, but it's possible given these data. The other possibility is that they understand that experiences can be variable, but they do not yet have the means for determining how they're going to vary for other people relative to how they will vary for themselves. And in the absence of that information, they fall back on a regularity that's actually useful in many circumstances, which is that very often different parties observing the same event will have the same experience. We're in a sad movie together and I'll feel sad and you'll feel sad as well. And infants may be relying on that as a strategy while waiting, as maybe the pre-reaching infants were waiting, for more information to disambiguate what the experiences should be. But that's as far as I can go with that. Now, I want to turn to the studies of social beings, and I'll try to get through this super quickly so we get to how children learn. Okay, 3 findings very quickly on one slide suggesting that there's a distinct system for representing social beings. Infants are highly sensitive to faces that are looking at them. When people change their facial expressions and their facial movements, they tend to imitate them. When people are looking straight ahead and then turn to the side to look to an object, they will shift their attention to the same side that the other person has shifted their gaze to. These abilities are all shown by non-human primates as well as by human infants, suggesting that this is an ancient system. And I think these findings also suggest that the system centers on interconnected abstract concepts of social engagement and shareable experiences that occur in states of engagement. But core social knowledge is limited. Infants up until about 10 months, 9 or 10 months of age, like people who imitate their social gestures and their emotional expressions, and they'll tend to smile at them, but they're completely unmoved by people who imitate their actions on objects. Infants also tend to view when other people imitate them, they view that imitation as social if it involves purposeless actions like waving your hands or jumping up and down, but not if it involves instrumental actions interactions on objects, suggesting that infants can represent a person either as an agent or as a social being, but not as both at the same time. They can't represent one action as simultaneously social and object-directed. And that may be why, until about 10 months of age, infants don't seem to have any notions of actions that are both social and instrumental, like gift giving, or competition over resources, or cooperation or helping. So it's an ancient, limited system, I think, distinct from the agent system, and that raises the question, does it support infants' learning? And this is the last experiment I will tell you about. Well, actually, I guess I have a slide that leads up to it. There have been lots of studies. There have been lots of studies that have shown that when you present babies with characters that they don't know, so they're just third-party observers to social interactions among other characters, they expect characters who imitate one another to affiliate with each other. They expect characters who comfort younger characters, smaller characters making crying baby noises. If two adult characters seem to comfort the same baby, they expect them to affiliate with each other. But what wasn't revealed by any of these studies is what's the function of these abilities, and might they guide infants' learning about their own social world? And that's the question that Ashley Thomas, who also gets all the credit for the saliva sharing studies that I won't talk about, has been exploring with Rebecca Sachs and me recently. Here are some studies over Zoom that she has conducted. Now, for these studies, she first works with parents and gets parents to make movies of themselves using their webcam, in which they're staring straight ahead and then making nonsense noises and looking to one side or looking to the other side. And then she takes these movies and digitally manipulates them to add puppets to the movies so that she can present infants with a movie on their laptop screen at home, in which their parent turns to a puppet, the puppet says something to the parent, and the parent imitates the puppet by repeating what they said. So the structure of the study is there's two puppets. Parent imitates one puppet, does not imitate the other puppet, and then the parent goes away. The two puppets are left. They move their mouths in synchrony, and the baby hears, "Hi, Brian, how are you?" And the question is, Brian being the name of the baby, the question is, who does the baby think knows their name? Is it the person that their parent imitated? So the full design of the study is every baby is run through this study twice with two different adults and two different sets of puppets. One of the adults is their parent. The other adult is the parent of another baby in the study. They get to see the name calling, and they also get to see control events where puppets dance to music. There was never any differential looking at during the control events, so I won't show you that. I'll just show you they're looking to the puppet who called their name. And what you see is that when that puppet had been imitated by their own parent, they looked to that puppet when they heard their name being called. But when they saw a puppet who had been imitated by another parent, they did not. So it looks like they're making an inference about who's connected to them from information about who is connected to their parent. But what this study didn't yet tell us is what kind of inference are they making? Is it about a trait, or is it about a relationship? This person is part of my social network. So to get at that, Ashley's done more studies. I'll tell you just one of them, where, again, you have a parent condition and a stranger condition. But in addition to having conditions in which they see puppets experiments in which they see puppets who face them and hear a voice calling to them by name, there's a comparison condition in which they see puppets who face away from them and hear a voice calling the name of another baby in the study, right? So if they just think these puppets are more likely to be friendly, you should see the same effects in the two conditions. But if you think it's really about them, you'll see different effects. And what she in fact gets, looking both at first looks and also total looks, oh, I'm going to be shut up soon.
It makes me be the bad part.
Yeah, okay. Is that the only effect is when they've seen their parent, the puppet imitated by their parent, calling to them, not calling to anybody else. So final study, is this only about the baby? Is the baby only concerned who's connected to me? Or is the baby also concerned who's connected to the people that I care about? Last study I'll tell you about, I promise. So to get at that, Ashley did one further study where she now begins with two puppets, one of whom calls the baby by name, and the other dances in an equally engaging fashion. Babies are equally interested in these two events, but shows no sign of individual recognition of the baby. And then they see events in which an adult expresses distress. The two puppets are present. They turn toward the adult. And the question is, who does the baby think is going to comfort this adult in distress? And the baby is run through two experiments, one in which the adult is their own parent and the other in which the adult is the parent of another baby. And as you can see, when it's their own parent, they expect the parent to be comforted by the puppet who knew their name, not by the other puppets. So it looks like they're not only learning who's connected to me, but what are the contours of my social world. They're starting to learn that in infancy. So I think what we have here are three distinct and limited, but unitary and abstract systems of core knowledge. A system focused on objects that move, on agents that act, and on social beings that engage with one another and share experiences. I think we also see evidence that infants don't readily combine these systems, even though two of the systems, at least, focus on the very same individuals. But when an individual is acting on an object, that engages one system. When they're engaging with another individual, it engages another. But children's fast and flexible learning can't depend on these systems alone, because they're all shared by other animals, and other animals don't undergo this explosive cultural learning that you see in children after the first year, and because core knowledge is limited in the ways that I've already described. So that then raises the question, what accounts for infants' uniquely human learning? And clearly, I don't have time to address that question now. I have slides addressing it. I did not, this is not the first time this has happened to me, that I've confidently thought I would be done in 45 minutes and I wasn't. But let me just say that I think we see hints of an answer if we look at another developmental change that occurs over the first year of life. And actually starts before birth. And that is that over the course of the first year, children learn a great deal about the language of the people in their social world. They learn what it sounds. They learn about language at all levels simultaneously. They learn about its phonology. They learn about its prosody. But they also learn the meanings of words, starting with recognizing their own name at about 4 months of age. They learn the grammatical distinction between function words and content words. And they know that they come to discover that content words refer to things in the world, whereas function words refer to relationships among those things. All of this they learn before they start to talk, and also before they start to talk, by learning these things about the language that people are speaking, they learn things about those people, and they learn things about the world that those people are speaking about. About the people, I think they learn that they are social agents whose actions can be simultaneously social and agentive. And I think they learn this when they hear people saying things like, look at the cup, look at the bottle. Look is inviting the child to engage with them and share an experience. Cup or bottle is inviting them to share an experience of an object, okay? I think this brings a new conception of people and their mental states. But it also gives children an extremely useful tool for learning about the world, because people are agents and therefore speak efficiently, and they are also social beings, and they therefore speak relevantly and informatively and helpfully. And whether people are speaking to the infant or to somebody else or to themselves, when they talk, they make distinctions in what they call things that reflect the distinctions that they think are worth conveying and relevant in the situation in which they are in. So if in an experiment by Shu and Carey, where a 10-month-old baby would normally not be able to tell you whether there's a cup, a shoe on one side and a duck on the other side of a screen, when they hear somebody calling to them and labeling those objects with different words, They'll infer that there's two different objects there, even if they've never seen anything. Person just looked into a box and said, look, a blanket, look, a toma. They'll infer that there are two objects in that box because you wouldn't go to the effort of using two words if you were only describing one thing twice. So language becomes an incredibly useful source of information for children to discover what the cultural distinctions are in the world that they're living in. And I think this is a beginning hint to how children come to learn so fast and flexibly about the particular environments they're in, even though the core knowledge that they're equipped with is utterly uninformative about the differences between one environment and another, since it only centers on these abstract concepts that apply in every environment in exactly the same way. And I think with this learning system, we get engaged in a process that leads to the situation we find ourselves in as adults, where the vast majority of the things that we do not know from our direct experience. We know from other people, either people we know directly or people who reach us through news services or social media or other things. I think this is both our greatest gift for learning and also an extreme potential source of vulnerability because we're going to learn most readily from sources that we trust, and if we don't all trust the same sources, that can bring us lots of problems. And then the parting hope of this talk, had I been able to give the last third of it, was...
For an hour now.
Okay, I'm done. I think maybe if we understand all this stuff better, we can start to deal with some of those problems. Thank you.
Thank you.
Oh.
Yeah, we have time for one or two questions.
Hi, I have a question about running the studies with the babies over Zoom. I actually used to work in Karen Wynn's lab before it shut down, so that's pretty interesting to me. But I remember learning in one of my classes that some things can't be learned on a screen. Like a baby can only learn to differentiate the phonemes of a non-native language, like from a speaker, not from watching a TV or watching a movie or someone on the screen. So I'm wondering if are there other limitations that you've encountered that cannot be learned through the screen?
That's a great question. The study that you're talking about is actually really interesting. It's a language learning study, and kids are exposed to a Chinese speaker, and they either have the Chinese speaker come into their house and talk to them directly, or they see a video of the Chinese speaker who's gone into somebody else's house and talked to the people there. And there's no question that the non-interactive video led to no learning whatsoever. Just like children don't learn language from the radio, they don't learn language under that situation. What we do over Zoom, though, is interactive video. So there's a real experimenter there who talks to the baby at the beginning of the study. That mom is involved in setting up the study, and mom is conversing with the experimenter at that time. The baby gets to see all of that. These babies also were being tested during the pandemic, which means they're interacting with grandparents over video and other family relatives. It was really the ideal time to run a study. And but I have to tell you, I was very pessimistic when we started working with Zoom. The reason we started working with Zoom is that there were grad students in my lab who were highly optimistic about it, and they talked me out of my pessimism, and so we tried it out. But I thought there were 100 reasons why these studies wouldn't work, and you've mentioned one of them. Another reason why I thought they wouldn't work is that the environments would be so variable and full of distractions. We're testing kids in their kitchens. There's dogs running around. The phone is ringing. I mean, all kinds of distractions. And we're measuring looking time. I thought this will never work. It works so well. The babies are so much more relaxed in their own kitchen than they ever were when they came into my lab and we went into the sound attenuated room and we turned the lights down, and they would look around like, what kind of weird environment is this? And the parents would sometimes look a little ill at ease. At home, everybody is relaxed. The kids are watching the videos. It works super well. And we haven't yet found a situation where we can run the tests at all that hasn't worked as well on video as it used to work in the lab generally. For most of our studies, we never want to go back. However, there are things we can't do. And one of them actually was a study that was maybe going on in Karen's lab when you were still there, looking at whether presenting kids with plants. I really wanted to do these studies, present kids with plants and see whether they would distinguish plants from living plants from inanimate artifacts by their forms and functions. And for that, the outcome measure that Karen used was latency to touch an object. Would they be more hesitant to touch a plant than to touch an artifact? And that I don't know how to do over Zoom. So we haven't been able to run everything. But I think you're absolutely right that kids are predisposed to learn from people that they feel socially connected to. It's just that in the pandemic era, you can achieve that with interactive video. Yeah.
Hi, thanks for the really wonderful talk. I just wanted to ask a question about the neonatal kind of imitation that was featured several times in your talk. There's some recent work that suggests that there are alternatives to the imitation theory for the neonatal work. Like one of them being that for very young babies and neonates, they tend to make stereotypic movements, and when they see a human, they're excited and they're more likely to make those gestures. So, those work they haven't been reliably replicated, and theoretically there has been lots of interesting papers that discuss these alternatives. I don't think from the core knowledge perspective, it doesn't make my perspective, it doesn't make a huge impact to the extent that you see this in other primates as well. But I just wonder if, and of course, imitation plays a huge role in development. I just think maybe a little bit later.
So are you talking mostly about the current biology paper that came out 3 or 4 years ago?
Hayes, and there was also
I don't
BBS
read that. I don't read that as
paper.
a non-replication of the imitation studies. What the original imitation studies had shown, this, by the way, is all work by Andy Meltzoff, who has a nice reply to that current biology paper in Developmental Science. But what the original imitation studies had shown is that not that infants are motorically capable of precisely imitating what someone else does, not at all, but that if you give them enough time, they will attempt to reproduce as best they can the movements that they saw. And they will not only do that immediately, they'll do it after a delay of an hour, and they'll do it after a delay of a day if they see that same person again. Now, what was done in the current biology paper is they saw, the babies got to see a single person. They did one gesture. They gave the baby, I think, a minute to respond, maybe 30 seconds, not very long. Then they did a second gesture. Then they did a third gesture. Then they did a fourth. Different gestures each time. That had never been done in the original imitation literature. What they reported is that babies imitated all the gestures, but they didn't imitate it in that first 30-second window. It would take them longer to produce the gestures over time. And what Andy Meltzoff has argued is it was because they used that method that what they found at the end was, yes, we see all these gestures, but they're not immediately following what they saw before. And Andy agrees it doesn't occur immediately after. But he argues that it does occur. And the paper where he argues this draws both on the data from human infants and also on data from studies that he wasn't even involved in that were conducted with monkeys and with chimpanzees that showed the same effects, this very slow, delayed, partial reproduction. By the way, what I think is interesting about imitation, for years I was puzzled by imitation. Why are babies doing this? I think the reason that they're doing it is it's the one reliable signal that they're able to give to someone, that they're attending to that person, and they're motivated to engage with them in the moment, right? They can't use language to say that. They don't have any specific cultural knowledge that they can draw on to indicate that to somebody. The one thing they can do is copy somebody's action, and as something that's very unlikely to happen simply randomly by chance if you weren't both attending to that person and motivated to signal your state of attention and engagement. So that's all I think that the imitation is about. It's been eliciting controversies, though, for 40 years now, since the original reports in the 70s, and it's clear that these are very subtle phenomena that you see early on. I wouldn't put a lot of stock on this being full-blown imitation, but I do think it's saying something about a baby's effort to signal to somebody that they're engaged with them, maybe in the same way that these kind of movements that a neonate will engage in might be an effort to signal, I'd really like to be able to reach for that thing, even though I can't do that right now.
One last question from Joanne.
I'm interested to hear you say a little bit more about the special role that language plays in sort of human cognition. Because we've talked about all of these different core systems, and they're sort of separate, and we can't use them at the same time. But then you were saying something really interesting right at the end, and I want to give you a chance to say a little bit more about this. About how language is an interesting sort of integration of some of these systems. And it seems like really plausible for me when it comes to like maybe object and social stuff. But I was wondering if other systems get integrated by this sort of language process as well,
yeah. That's actually what my whole second book is going to be about, because I think there's many cases, not only infants developing understanding of other people, or infants developing ability to categorize objects as instances of kinds, which are the two things that I think we see infants using language for at the end of the first year, but also other abilities like their discovery of the natural numbers, their discovery of other symbol systems, and developing abilities to communicate with other people by means of spatial symbols, for example, of the sort that will eventually figure in maps and reading and pictures and things like that. So yeah, I think there are many domains. As far as I can see, actually, in every domain where you see children's knowledge taking off before they get to school without anybody instructing them in anything, it looks to me like it's associated with changes in their language. Theory of mind is another great example of that. So then your question, what is it about language? Now, initially, I thought that the primary feature of language that made it such a good tool for learning about the world was that it was a compositional system. So where once you know the meanings of words and you know the grammatical structure of a sentence, you get the meaning of the sentence for free. So if a child knows that a word, when they hear an expression like, look, Lori, a duck, okay? If they know the meaning of the word look, if look indicates for them an invitation to engage and share an experience, and it's directed at a specific person, so they know it's for them, and it's followed by a duck, and they know that a duck refers to a kind of an object, at least this individual object, if not yet a kind of object, that then if they hear this as a sentence expressing a specific thought, the thought has both social content and its object directed. Okay, so it's both, and I think that suggests that it's reflecting a mental state that's both phenomenal and intentional. And they're getting that from the combinatorial properties of language. But I now think, actually, there's another related aspect of language that might be just as important, which is that babies seem to already know early on that they can engage with other people to share experiences of emotion, of action, with imitation and things like that. But I think what happens at the end of the first year is that they come to discover that they can share experiences that cut up the world more finely than just experiences of an object. They can share experiences of an object under a particular description. So, for example, when a person says to a kid, look at that dog over there, that's our neighbor's dog. Or look at that dog, that's Fido. Okay? They're using two different words. Now, if babies expect people to be efficient, they don't expect them to use two different words to convey the same experience. But they're talking about the same object, so they must be using two different words to convey two different experiences of that object that can be shared with the child. And I think this may be really, really important for learning. Think about how you could teach somebody that the stars up in the sky are enormous suns, as large or larger than our sun and very, very far away. You could point at a star all day long, and you're not going to be able to convey that. Language is an ideal medium for conveying those kinds of experiences. And I think that's the kind of learning that kids get into at the end of the first year of life and throughout the preschool years. And we continue to do it throughout our lives. But it's really central, I think, to kids' learning over the course of the preschool years. And it's just based on fundamental assumptions that people are social, and therefore they will share their experiences with kids. But they also are agents who act on objects, and so they can share experiences of objects, and they will act efficiently, so that when you see what they choose to say and what they choose not to say, you can infer from that what they see as relevantly alike in the world and what they see as different, what distinctions they think need to be made in the situation they're in to be sharing experiences within that situation. Does that make any sense? Okay, those are kind of the general ideas about language.
Awesome. So students, we're going to go upstairs to the seminar room, but first let's thank Professor Spelke.
Thank you all.